floating points, numbers, and money. So in this article, we'll delve into the world of numbers in programming, specifically focusing on floating point numbers. So floating point numbers are number system where the decimal point, the point in the number can float around. That's essentially what floating point numbers are. They represent a wide range of values, both large and small, also fractions, like not 1 divided by 3, but the representation of the function as a number, okay, as a digit. So floating point won't represent exactly 1 divided by 3, but it would have something like something like numbers, right? It should be, right? This should be the number, basically, but in binary. Floating points cannot represent exact numbers because, floating points represent numbers. Let's say this. Okay, so they represent it in, this is going to be the number, right? And this is going to be the exponent. The dot is here. So basically, because we are dealing with binary numbers, then when we have the dot here, then here we have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So this represents 1 or 0, this represents 2, and this represents 4. So if we want to represent the number 3, we can just put 1 and 1 here, and we get 3. If we want to represent the number 5, we can put 1 here and 1 here, and we get 1 plus 4, which is 5. So we can represent any whole number, right, in the range. But we have a problem with what happens after the dot, because after the dot, this becomes 2 to the power of minus 1, 2 to the power of minus 2, 2 to the power of minus 3, right? So basically we have half, we have fourth, and we have 1/8, right? So it's impossible to represent, like, how do I represent 1/3, right? I cannot combine this to represent 1/3. So what it would do is it would ask, do I need to put a 0 or 1 here? So 0 because half is larger. Okay, now I can put 1 because 1/4 is smaller, so I can add it. And then it would start adding and removing some numbers until it reaches the limits of number of bits that it has, and we would reach numbers like this. So this would introduce some inaccuracy, and now multiply this number by other numbers, and you get a whole mess. So are floating point bad? No, because if you're dealing with something which is not exact, like scientific calculations, graphics, game development, it's perfectly, they run very fast. Why do they run very fast? Because if you want to multiply a number by 10, then all you need to do is to shift the bits, and shifting the bits, right, would multiply it by 10, and this would be super fast. So you get all the benefits of fastness in expense of accuracy. Now, what happens if you need the accuracy, right? You need the accuracy. So you have other alternatives, and the other alternatives are going to be like big integers, decimal, or fraction libraries. Actually, for monetary types, then you actually can just use the big decimal, and let's see an example of this. Or there is also a monetary library. So as you see, with big decimal, we create in Java a new variable of big decimal, and we actually specify the monetary value with a string. And then we have another big decimal, and we represent the monetary value with a string. So this, you can already imagine that doing calculations on this would consume much more time than standard floating point numbers, but you will get the exact values. This is the benefit of it. You can define how much precision you want, and then you will have operations like multiplier, etc. In addition, if you are specifically using money, then you can actually just use the Java money library, JSR274. And this would provide you a comprehensive API for dealing with the monetary values. And if you need actual math, then you can use Apache Commons Math, which would utilize big decimal. So big decimal can solve it for monetary, JSR274, Java Money, or Apache Commons Math. So with big decimal, you can specify exactly the precision that you want, right? So this represents $1 and 22. You actually represent it in a string: $1, 22, 23 cents with hundreds precision, and you can also go ahead and have higher precisions, right? You can also specify in Java a monetary library the actual currency. So this is it. We discussed, you can read this article, it's much longer and much more details. Search in Medium for um, floating point, numbers, and money, right? So this was a brief overview about floating points, why they're imprecise, why we do want them. We do want them because they're fast. You can just apply internal logic by the computer. And when we deal with money and we want preciseness, then we can use big decimal, which consume more memory, are slower, but would provide you the precise answer, the standard trade-offs that we have on a daily basis.